Good morning, students. Today we'll discuss problems on canonical form. Before going to the problems on canonical form, in the last class, do you remember what we discussed about the min term and the max term? Your min term is nothing but SOP, that means all product terms. All product terms. All product terms. Product of all variables. Product of all variables that is logically added. Logically added is called as sum of product. Logically added is called as sum of product. In min term, x is nothing but 1, x complement is nothing but 0 and x plus x complement is equal to 1. These are the basic things you need to remember to solve the problems on canonical form. What do you mean by canonical form? It is an expression of composed entirely. It is an expression is composed entirely with sum of product is called as canonical form of sum of product. Canonical form of sum of products. When we are discussing a sum of product, do you remember here x into x plus y plus z and x plus yz? Do you remember this? These are how we have distributed x plus y into x plus z. This is your POS. Then this is xy plus xz. That means it is a composed of all the terms added. Hence it is SOP. It is composed with a multiplication. Hence it is POS. Here it was not distributed properly. Do you know this is a distributive law? These are the things was distributed such that we get product terms. We get product terms. All product terms are added is called SOP. All sum terms are multiplied are called POS, product of sum. SOP is nothing but sum of products. Sum of product. That means this is a sum of these two products. These two products. That we can write in the min term form also, that we have discussed in the last class. Now we will move for solving the problems which has given in the canonical form. See here, they will give one expression. They will give one expression that you need to convert it into canonical form of SOP. Canonical form of SOP. Before going to that, you need to know the rules of that. First rule, identify the missing variables. Before that, check whether expression is in SOP or not. If it is SOP, you can continue. If it is not, then convert into SOP. Convert into SOP if it is not. Then identify the missing variable. That missing variable you need to add to the term missing variable plus missing variable complement. Its complement. How we can write? Suppose in the xy there is a z missing. If you want to add, this is a missing variable plus missing variable complement. This you need to apply to include the missing terms in missing variable into the terms. Once you have been identified and included, then add all the terms together And suppose if you have two terms like this, two different terms in the expression, x plus x can be written as x. That means remove the duplicate terms. If you have two terms, write only once, not twice. These are the steps you need to follow while solving the canonical problems. First we'll move for SOP, then we'll go for the POS. In the SOP, x is 1, x complement is 0, x plus x complement is equal to 1. Based on that, we are going to solve the problems. Okay, first problem. X complement y plus x complement z complement convert into canonical form of SOP. Canonical form of SOP. First I have been written up. That means convert into canonical form of SOP. Canonical form of SOP. Check whether the given expression is in the SOP form or not. See here, these two are the product terms. These two are the product terms. It is been logically added. Logically added. Hence, it is in the SOP. The given expression is in the SOP form. Then we can apply the rules for this. The given expression is already in the SOP form. How? Then how I can identify how many variables, how I can identify the missing variable. Check the expression, how many variables are there. X is there, yes, y is there, x complement, so x I have written, z, that means 3 variable. The given expression is in 3 variables. That expression is x complement y plus x complement z complement. Now you should apply the rule number 1. What is the rule number 1? Identify the missing variable in each term. What are the terms we have? X complement y is one term. Second one, x complement z complement. There are 2 terms are there. Here z is missing. Here y is missing. Is it right? Here z is not there. Here y is not there. Then how I can include the missing terms here into z plus z bar. Here y plus y bar. In SOP term should be plus term. Okay. So here these 2 are the missing terms we have included here. Okay. Then after that distribute the missing variable into terms. That means the first one, x complement y, z plus z complement. Apply your distributive law. What you will get? X complement y into z plus x complement y into z complement. We got this one. Now see, now the term contains all the variables, right? Yes. A term should contain all the variable, then only it is in the canonical form. Canonical form is nothing but a term should contain all the variables with or without a complement. With or without a complement. Say. Now earlier we have x complement y, that we have included the missing variable. We got 2 terms. Then second one, x complement z complement, y plus y complement is missing. How I can write? X complement z complement y plus x complement z complement y complement. Arrange and write. That means rearrange according to the variable format. What you will get? X, y, z complement. Here y complement z. This is your second one. This is your first one. This is your second one. After including the missing variables into the given terms, we got these are the expressions. Then combine. This is a rule too. Combine 1 and 2. Combine 1 and 2. If it is 3, combine 1, 2, 3. How many terms are there? All the terms combined. Now what you will get now? X complement yz plus x complement yz complement. This is your first one. Plus the second one. X complement yz complement. X complement y complement z complement. We got this one after combining. And now you check, is there any duplicate terms? That means remove duplicate terms. That means if you have any two terms are same, write down only once. Check. Is there this one again? No. Then copy down. X complement yz. Is there this term? Yes. These two are there. This is your repeated term. Write down only once. According to your x plus x can be written as x. Write only once. According to your idempotence law. Then copy down only once. X complement y, z complement. Then this one no need. This is a repeated one. Then x complement y complement z complement. This is your canonical form of SOP. This is your canonical form of SOP. How to write the min term for this? Min terms for this. Do you remember M0, M1, M2? That we need to write it now. So before writing, please remember your 4-to-1 format according to this. See, if the variable is complement, it is 0. Uncomplement is 1. Is it a variable complement? Yes, it is 0. It is an uncomplement 1, 1. Are you getting? This is complement 0. Uncomplement 1. This is complement 0. Then here 0, 0, 0. According to your 4-to-1 format, what you will get? 2 plus 1, 3. That means M3. Plus 2, 0, 4 to 1. 4 is not there, 1 is not there. What you will get? M2. Are you getting? All are 0. This is M0. This is your min term representation. This is your reference have been written. This you should remember according to your finger computer. How I have been written 0, 1, 1 according to x equal to 1. That means uncomplemented variable is nothing. Bar illa andre 1. Bar idre 0. That means if the variable contains the complement, then that is 0. If the variable does not contain the complement, means that is 1. Then this is your min term representation. Write this one exactly with the SOP. How I can write? Do you remember your sigma mi? Yes, sigma mi of, write according to your numbering format, ascending order, 0 first, 2, 3. This is f of x, y, z can be written in the SOP form. This is your SOP form. Hope you understood. So here first I didn't check whether the given expression is in the SOP or not. If it is SOP, apply the rule. Yes, the given expression is in the SOP, hence I am applying the rules. What is the rule? Identify the missing variable in the term. First identify how many variables are there. In that, find which variable is missing. Here xy is there, z is not there. Here xz is there, y is not there. Include that with the complementary law. Include that missing variable plus missing variable complement, both you need to include. Once you have been included, that distribute that into the distributed form in the SOP. Now you got the distributed SOP form. keep it as a first equation. Second term, second equation. Combine both the equations, then identify the repeated terms in the combining in the rule 2. If any repeated terms are there, copy down only once, not twice. Then once you have been written, this is your canonical form of SOP. That one you write it in the min-term format. How I can write the min-term format? Using your finger computer. Write the m terms. Then sum of, that means auto sum of these, plus is compulsory, right? Plus means sum of what? Min terms 0, 2, 3. This is your canonical form conversion. Shall we move for the next problem? Second problem, x complement y plus x complement z complement. See, this is I think the same problem with the x was added. That means our expression now contains 3 terms. Expression now contains 3 terms. See, x is there, y is there, z is there. Then the expression contains how many variable? 3 variable. Yes, it is already in the canonical form. It is already in the canonical form. This is one term. This is one term. This is one term. Okay. So 3 terms are there. Identify the missing term. Identify the missing variables. Missing variables in each term. That is your rule 1. X doesn't has y, so include the missing variable with a missing variable and its complement. Z is not there, z plus z complement. This is your first equation. X complement y, z is not there, z complement. This is your second equation. X complement, z complement, y is not there, y complement. This is your third equation. Distribute all into the equation now. So write down the first equation, xy plus y complement, z plus z complement. So while including, at a time should not include both. First apply the distributive law for only the first missing variable. You will get xy plus xy complement. Are you getting? If 2 missing variables are there, if it is 3 missing variables are there, include the missing variable into the given variable one by one, not at a time both. So now you got this one. Now include z plus z complement. What you will get? xy z one time, xy z complement one time. Are you getting? Plus xy complement z one time, xy complement z complement. This is your first equation what you have been got. First equation. See, 2 missing variables are there. You need to get 4 terms. Then according to your second equation, x complement y, z plus z complement, what you will get? Only 2 terms you will get. X complement y z plus x complement y z complement. This is your second equation. Second equation. Third equation, x complement z complement y plus y complement. You will get x complement. Can I write according to your alphabetical order? X, y, z complement. Then here x complement, z complement, y complement can be written as x complement, y complement, z complement. This is your third equation. Combine all the equations togetherly in the rule 2. According to your rule 2, what you will get? Combine the equation xyz complement xy complement z, xy complement z complement. Second term, x complement yz, x complement yz complement. Third equation, x complement yz complement, x complement y complement z complement. Identify the repeated variables. Any is there? Is there any error x, y, z? No. According to our rule 3, remove. What remove? Duplicate terms. Remove duplicate terms. After removing x, y, z not repeated. Is there this one repeated? No. You will get x, y, z complement. Is this one repeated? No. X, y complement z. Is this one repeated? Nowhere. X, y complement z complement. Then among this x complement y, z, here identify these two are repeated, right? Write down only once. X complement y, z complement. This no need to copy. X complement y complement z complement. This is your canonical form. This is your canonical form. Then write down that one into min-term format. See, all are 1 1. 1 1 1. 1 1 1 1 means? Yes, M7. Then 1 1 0. 1 1 0 means? Yes, M6. Then this one is 1 0 1 0 1. 1 0 1 means? SM5. Then this one 1 0 0. Are you getting? No place here, so I am writing here 1 0 0 SM4. Then here 0 1 1. What you will get? M3. 0 1 0. What you will get? M2. All 0 0. Yes, you will get M0. Did you got it? Did you got it? So this is your M7, M6, M5, M4, M3, M2, M0. So how I can write this one? In the canonical form of, can I write it here? So now I am writing in the here. So this can be written as f of x, y, z can be written as sigma mi 0, 2, 3, 4, 5, 6, 7. This is your final sum of product. Sum of product. Hope you understood. First identify the missing variable. In the first term, 2 variables are missing. So at a time don't distribute. So first missing first variable. What you will get along with that the second variable. Along with the second variable you need to include. So if 2 variables are missing, then you will get how many possibilities? 4 possibilities. If it is only 1 variable missing, you will get 2 different possibilities. Why? Because y plus y complement. Y, for the y you will get 1 term. For the y complement you will get 1 term. So that 2 will be added to the z and z complement. 4 variables we have included. So you will get 4 terms. That is, keep it in the mind. If 2 variables are missing means we have written y and y complement 2, z and z complement 2. That means totally we need to get how many terms? 4 terms we need to get. Okay. Thank you students. In the next class we will discuss which is not in the SOP form. First convert that into the SOP, then identify the same steps. We'll follow that. That we'll do it in the next class. Thank you students.